Okay, so it's 7:30. We'll get started. Welcome back to week 2 of Intro to Backend. This week we'll be covering databases, which are going to be very exciting. But yeah, before we delve into the topic for today, have a few logistical announcements to make. Also, if you've noticed, I'm giving lecture this week, and Jessica will be giving demo this week. So we'll be taking turns every week. So that's kind of how the flow will go. So yeah, a few announcements. So PA1 has already been released, and it's due in 2 days on Wednesday. As you all know, you have 6 total step days for the semester, and you can use up to 3 for PA1 if you're already like, I don't know, like packed with prelims or something, I guess. But just to kind of reiterate a few things that students missed last year in PA1, like the very first assignment, know that demos are going to be very, very similar to what the assignment's going to be like. So if you're ever stuck on PA1, just like review the demo and you'll probably get it. Use the test cases file. So people sometimes like test it with Postman and like, thought that they were correct and then just submitted that to us. Make sure you use the test cases file that's uploaded on Ed, which is part of an announcement that Jessica made. Make sure you save your Postman collections like I showed at the end of last demo. Make sure you write documentation, that's part of your grade as well, and follow the API specs exactly. So testing with the test cases file and the Postman are both going to be important. Also, I do want to mention one thing. So we changed the port to be 8,000 this year because 5,000 is reserved for something with the M1 Mac. And we forgot to update that 5,000 in the test cases file. So if you go to the test cases, which is this post right here, and you click on this attachment, it'll like give you all this, which you can copy and paste into a file. You can do Command F or Control F if you're on Windows and look up 5,000 and replace all of these numbers with 8,000. Or if 5,000 working, that's okay as well. We'll use both numbers to check your assignment. But yeah, sorry about the inconvenience. The M1 Mac stuff kind of messed us up last semester, so that's why we're making that change. So this will be part of the recording as well, so I don't want to spend too much time on this, but that's just one quick thing to note. Yeah. Cool. And then as for free miscellaneous stuff, please fill out the weekly feedback form. That'll be part of your grade. It'll allow us to adjust depending on like feedback that people give us. They're also worth 5% of your final grade, so might as well just get them done. It's like a minute each every week. And the Kahoot leaderboard is also published, so that's on our Ed. So that's also here, right? Again, like last semester, we're going to be handing out prizes at the end of the semester if you do well in these Kahoots, so a little incentive for y'all to come. Even though I know it is getting cold and kind of annoying me too. All right, any logistical questions before we move on to the actual content for the week? Yeah. So yeah, great question. If you go to the backend textbook, there's like this link on the sidebar right here that says weekly feedback form. That's there for your convenience. It's also there. If you go to like assignment handout for every single week, it says like fill out the weekly feedback form right here and right here. So yeah. Please also fill out this demographic survey. I think that's like a one-time thing that we're trying to start this semester, for the sake of seeing where all of you come from. So that's also right here in the assignment handout of PA1. Any other questions? Awesome. Okay. If that is the case, we can get started with the topic for the content for today. So just to quickly recap what we learned last week, right? So we have a client-server model. Clients are, the devices that you're all going to be using, phones, laptops, tablets, whatever. Then servers are also computers, but they're like massive computers. Like Google has a server. Again, back to Minecraft example. If you use Minecraft has a server, right? So those are huge laptops or computers that you like connect to using the internet. And clients send requests to servers for like certain resources, and servers reply to these requests with responses. So the way it's gonna, the way requests are structured is as such. So a request is initiated by a client, right? It has a certain URL that you're going to be hitting. And the URL has like a few different parts. Refer back to last week's lecture if you forgot what they are. There's like methods, right? So like, do you want to create a resource? Do you want to retrieve a resource? Do you want to update a resource, delete a resource? And then we're going to be sending in content through the request body if needed, right? So like when you're logging in, you want to send your username and password. Stuff like that would be in the request body. Cool. So in response to requests, we have responses, right? So responses are triggered by client request. Responses are only returned when we make a request, right? It's kind of like a confirmation that we actually made the request and it was successful. And the response codes, as we talked about last week, are indicators, high level indicators of like what kind of happened. So like 200 would be like, oh, we successfully made the request. 201 is like we successfully created a resource. 404 was like not found. 500 is like your backend broke because bad code. And a lot of responses will also contain a response body that will contain information that is relevant to your request that you made. So to kind of visualize this, right? We have a client and a server. The client is the laptop, and the server is this big server that's being hosted elsewhere. We make a request over the network, over the internet. The server then kind of retrieves, like kind of accepts that request, does some sort of data operation, right? So that's like updating a resource, like updating the Python dictionaries like last week, that kind of thing, and then it will return a response, which is kind of like a confirmation or data about like the request that you just made. Okay, I think that's most of what we covered last week. Are there any questions? And again, let me know if I'm going too fast. Cool. So that was last week. So this week, let's talk about data persistence. So last week, right, this was a Kahoot question. Do y'all remember what data structure we used to keep track of the data in our posts and comments and things? Yeah. Dictionary. A dictionary, a Python dictionary. So we initialize a Python dictionary in our Python file. And so what that means is that every time we run the server, every time we start the server, all the code in your Python file runs. But that also means that all your dictionary gets initialized to that same value every single time, which also means that if your server goes down and you start it back up, all your data is going to be wiped, right? It's going to start off at that original state every single time, which is not what we want. We want to actually keep track of the data that we've updated. So again, so this was last week, right? We initialize a post dictionary and we have like a post ID counter. But when we put the server down and then start it back up, this code is going to run and it's going to initialize a post variable to contain just this one post. So we don't want that. We want to be able to actually like update our data without a risk of it just disappearing because the server went down, right? So the way we're going to do that is this thing. Okay, so this is the deficiencies, right? Stopping the server means the data is lost. There's also no formatting enforcement. That's because Python dictionaries are really flexible, but that can actually kind of bite us in this specific scenario. So then our solution is databases. So what are databases? Databases are collections of organized information, right? So databases are kind of like designed to store data, right? That's the whole point of it. So it's easy to access, update, and manage data in a database. And you can think of it as like a collection of tables. So we're going to cover what tables are shortly, but you're going to have a table for like each type of data you want to be storing. So we'll cover this shortly as well. But for example, if you want to say like make Instagram, right? You would have a table for users, you would have a table for posts, and that kind of thing. Cool. Any questions so far? And again, the slides are going to be on the website, so don't feel too frantic about copying everything down. Okay, so this is an example of a table that would be in a database, right? So you can kind of think of it as like Microsoft Excel spreadsheet, except not. You have each column representing one thing, right? And each column has a descriptive name, and it also has a data type. So in this example, for example, we have an ID, right, which is just like integers. We have a name, which is a string, an age, which is also an integer, and hobby, which also happens to be a string. But you can kind of configure this however you'd like. So it's kind of like, similar to an Excel sheet. It allows us to store information in a really organized manner. So columns are representative of each data type, and rows are like each data entry. Cool. Everything makes sense so far. Okay. So this is in similar vein of last week's ID. We have an ID field that kind of like allows us to uniquely identify each of these elements in the table, right? So if I want to query ID 1, you'll find Gonzalo. If you ID query 2, you'll find Kate. And if you query ID 3, you'll find me. So these numbers are going to be unique for every entry in the database or in the table. And IDs are automatically set to increment, right? Just like we did last week. Cool. So let's let's think about actually like deleting one of these entries in the data in the table, right? So if let's say we delete the entry with like Gonzalo and we want to add another entry with Rahi in it, this is what the change is going to look like. So we have 1, 2, 3, right? Gonzalo, me, or Kate, and me. And once we actually delete and make that change, Rahi will now have a new ID of 4. So this is the same thing as we discussed last time, right? We don't actually want to be reusing IDs, right? Just because Gonzalo's ID 1 is gone, it doesn't mean that we want to actually reuse the ID 1. And there's like several reasons for this. A small one is like, if let's say we want to backtrack and be like, oh, what was Gonzalo's ID? We can like say, oh, it used to be 1. And that's not going to be like replaced with anyone else's. The bigger reason is time complexity. If let's say we have a table with like a bunch of users, right? We have like 10,000 users or something. And some IDs in the middle are like not used anymore. If let's say we want to reuse those IDs, we have to search through the entire list of like 10,000 numbers to see which ones aren't actually used. So for the sake of simplicity, we'll just like add 1 to the greatest one that's already been created. Hopefully that makes sense. Okay. So database is not the same thing as a table, right? So the table is like the visualization I just showed, but a database is a collection of tables. Okay, so if we're making Instagram again, we have a users table, we have a posts table, and all that is one database, and all that is also multiple tables, right? Yeah, so this is an example of something like a posting platform. We have 3 users, right, with their age and their hobby and their name. We have a post table with their name, description, and the number of likes, I guess, the post got. So this is an example of database. And one thing you have to note here is that, let's say we have like users and we have posts, and like some of the users, like the columns in the users table, correspond to like other rows in the post table. These tables are both going to have their like independent ID fields. So like one being reused in these 2 tables is like okay. And that's because if we want to look for the row with ID 1 in the post table, we'll look specifically in the post table. If we want to look for ID 1 in the users table, we'll go to the users table and look there. Yeah, so you're not going to have like a universal like whole like back and forth with like IDs being used. That's not necessary. So, right, this is a table in a database. This is a Python dictionary. What looks cleaner? I don't know. You tell me. But if you really like this one, maybe backend isn't for you. That's okay. Yeah. So that's the elegance of a table, right? It's much cleaner to look at, and it's much more easy for us to understand. So does that make sense? Table is just Excel. Don't ever say that to the backend lead. I just want to make an analogy for you guys. Okay, so what are some benefits of databases? Well, all data is structured, right? So that's really nice that we have that. What this actually means is like, say we have a users table and we have like a name field that's a string and an age field that's an integer, right? If you try to add a number, like an integer, to the name field, the database will throw an error because, right, like the data doesn't actually match with the data type of the column. So in a Python dictionary, again, it's really flexible. We can add any key value pair that you'd like, but in a database, it's like really strict of like what you can actually add to the database. And that strictness is actually beneficial for us because we can rely on like it having the data type that we expect it to have, right? So that's number one. It also scales well. So a Python dictionary, if we keep adding key value pairs, is going to take up a lot of storage, whereas databases, no need to go into nitty-gritty details, but it's very optimized to store data in an efficient manner. And the third thing is querying data, right? When you have huge databases, you still have that unique identifier that allows us to kind of uniquely identify each entry in the database, right? Which is similar to Python dictionaries, except Python dictionaries are like slower and more horrendous to read and all that. Cool. So let's delve into this querying data thing. Okay, so this is actually an example of like using a Python dictionary, right? Or like the Python dictionary that we used last time. Instead of storing the Python dictionary in like, you know, a Python file, what if we stored it in a JSON file, right? A JSON file is like similar to this, right? JSON is very similar to like what a Python dictionary would look like. So if instead of a database, we stored data in a JSON file, then if we want to look for each user that is like over the age of, oh, well, I guess I forgot to change that, but 18, right? Then we loop through every single user in the users.json file and check if like their age is like greater than 18 and then have to append it. Now this will look through every single element in the users.json file, which is already dirty enough and looks ugly. But this will take a really long time. Whereas if we used a database, our query, instead of being what, 6 lines of Python, looks like that. So this looks much cleaner, right? The star means all. So select all from users where the age is greater than 18. This is much more nicer to look at. So this is going to be the language we're going to be using to communicate with the database, right? And it's called Structured Query Language, or SQL for short. I'm sure a lot of you have heard that before. So SQL is going to be the language we're going to be using to access our data from our database. And oftentimes it looks much more elegant than multiple lines of Python code. Okay, that was also a lot. Any questions so far? Does that make sense? Cool. SQL. So again, SQL is a language for communicating with databases, right? It has multiple keywords that's reserved for creating, retrieving, updating, and deleting resources. So, you know, like in here, select is actually a retrieval keyword, but we'll cover like what the other ones are in a sec. So if we want to create a table, right? Create a table for like, I don't know, users or something. It'd be create table, and then the name of the table, and then we can specify the columns and the data types in the syntax like this. So an example of this would look like, right, like this. Like create table user with the ID being an integer, the name being a text, which is string, age being text, and email being like a set number of characters. So all this stuff will be in like SQL documentation. It's not super important that you guys like memorize all these keywords. But one thing that is worth mentioning is this ID field. So it's kind of long, right? There's like integer, primary key, auto increment. What do all those buzzwords mean? So integer is integer number. Primary key is basically like, this is the field we're going to be using to uniquely identify each user, right? So like a user will like have ID 3, and like primary key makes the ID like the relevant field to use when we're trying to access a specific user. Auto increment, as the name suggests, is auto increment. So like it'll go like 1, and then if you add another person, it'll be like 2, and then 3, and 4, and so on. How about inserting data? So now we have a table that already exists. How do we insert data into it? In that case, we can type insert into, and then the table name, and then the columns we want to actually insert the data into, right? So if let's say we have a users field, and we want to only input into like the name field and the age field, we'll specify those here. And then values followed by the values we want to enter. So an example of this will look like this, right? So if let's say we want to insert a user called John, age 21, and that email, this is what the SQL query would look like. One thing to note, which was in the previous slide, is if we're inserting values into every single column that's exists in the table, we don't actually have to specify what columns we want to insert into. The reason why this exists is because we can specify if some columns are like nullable, meaning we can enter nothing into it. So for example, let's say I'm making Instagram again, right? And I have like a description field in the users table. So the description is optional. The user doesn't actually have to fill it out. In that case, the description field is nullable because we don't enforce that each user has to have a description field. So in this case, right, like if we want to insert into the description field along with like all the other fields, we can omit the column thing. But if we don't want to insert into the description field, we can just like list out all the columns we want to insert into and not include descriptions there. Yeah, I see a few nods. Hopefully that made sense. Yes. Okay. How about retrieving data? So we saw this a bit earlier, but select is the keyword for select, like retrieving data. So we can specify which columns we want to be retrieving data from. So if you want to only see the names of like our users or the net ID of the users, we can specify those in the comma separated values of like the column 1 and column 2 stuff, and specify what table it's coming from. And selecting all, right, is like the star that you just saw earlier. So that's if you want to just see the whole table. This is the syntax for that. You can also specify some conditions. So we also saw this earlier, but if we want to look at all users who are 18 years old or older, we can do select, I don't know, star from users where age is greater than 18 or something like that, right? Make sense? All right, how about updating data? So updating data is this syntax: update table name, set the column to be whatever value, the second column to be another value. And for updating, we have to specify a condition, right? Because then we don't know which resource we're trying to update. So oftentimes it'll be like update a table name, set, and then like fields where ID equals something, because the ID is what we use to uniquely identify users. But actually sometimes like, we can like not use ID here. So an example for that would be like update user set, like, I don't know, legal equals truth, where users greater than 21 or something like that. Or sorry, age greater than 21. So the condition can be like ID, can be a field. It can be anything that we want it to be. So, right, a lot of times we'll be using ID, but like, I just gave an example of like when we don't have to necessarily use ID. And deleting data is delete from table name where condition is like something. If you forget this condition, by the way, it's just going to delete everything in your database. So if you write like delete like user, it'll just like delete everything in your users field. Don't do that. That's actually a meme that I pulled for like a Kahoot later today, but a bit of a spoiler, sorry. So like delete from user where ID equals 1. If we want to delete the user with ID 1, that's what this would look like, right? So that's it for, I think, the SQL commands. Are there any questions? Does that make sense? Was I not too fast? Databases, storing information. Cool. Okay, amazing. Then we can get started with the demo. This is no password.
Okay, hi everybody. So I'll get started with today's demo. We're going to be working in the terminal today with SQLite. With SQLite 3. SQLite 3 is a tool built on top of SQL, what Shingo just spoke about. It's basically, it allows you to store a database in a file, which is a lot more useful for, I guess, smaller projects. In real life, databases are stored in super large servers, uses the internet, things like that. But here, the databases are stored in a local file. To install database, to install SQLite 3, the instructions are in the textbook under chapter 2 databases. So now I'll get started on demo creating a database showing the favorite BOAs for the Intro to Backend core staff. So to get started off, we'll do SQLite 3. So now we're in SQLite 3. So we're going to start off with creating our table. So create table, and we're going to, create table. We're going to call it user because it's going to store all of our users. What's pretty cool about SQLite 3, it allows you to create multi-line queries. So even though I pressed enter and I'm on a separate line now, the query is not complete until I use a semicolon. So our first field in the query could be our ID. The type of that will be an integer. And as Shingo mentioned, it's our primary key. So all users have their own unique ID, and we're going to use the auto increment primary key. So that we're going to use auto increment so that no two users have the same key. And then each field is separated by a comma. Now our next field is going to be the user's name, and that's just going to be the type of that is going to be a text. Text is essentially the equivalent of a string in SQLite 3, and we're going to enforce the condition that the name is not null, because it's pretty important that in this table, we're enforcing that every user has to have has their own name. And then we're going to move on to the favorite boba, and then that's also going to be text. And then we're also going to enforce that that's not null, because we're creating a database all about favorite boba. So everyone needs to have their favorite boba in this table. And then lastly, we're going to have favorite topping, and that's going to be of type char 20. And this just means char 20. That also means it's a, favorite topping. Yeah, favorite topping of type char 20. And this just means that it's also a string, but it has a limit of 20 characters. And then we're going to close off with a semicolon. And then now we can use the command tables, and we see our table that we just created called user. Moving on to inserting users into our table, we're going to use the insert command. So insert, that's the command, into user, that's our table. And then the parameters name, favorite boba, and then favorite topping. Okay, and then putting in the values. So let's put in myself, Jessica. My favorite boba is, let's go with Thai milk tea. And my favorite topping is bubbles. Okay. And then now we can see that using the select command, select all from select user. We can see that with the first entries in there, ID 1, Jessica, my favorite boba Thai milk, and my favorite topping bubbles. So we can repeat this process, entering more entries into our table. So let's go with Shingo. His favorite boba is dirty milk tea, and his favorite topping is also bubbles. And then let's put in, that's just another person. Let's go with Maria. Their favorite boba is baby watermelon. That's a real one from UT. And oh, my bad. Okay. Yeah. Values. Maria, her favorite is baby watermelon. Okay. And let's look at the entries into the table. So as you can see, we have Jessica, Shingo, Maria, baby watermelon. Notice how both Jessica and Shingo have 3 entries, the last being bubbles, which is the favorite topping column, but Maria only has name and favorite boba. That's because the favorite topping field was optional, so you wouldn't get a error when you don't include a optional field because it wasn't specified that it couldn't be null. So if we repeat this process and we say, for example, let's add in name, values, Mateo. Okay, arrow stepping, not null, constraint failed. That's because originally when we first defined the table, the favorite boba field was added the precondition not null. So moving on, let's try selecting different information from our table. So we already saw the select all feature, so it selects all users from our table. We can also select specific users. So let's select name from user, and this returns all of the names in the table. We can do multiple parameters, multiple fields at once. So let's do name, favorite, boba, user, and that returns both the name and the field favorite boba. You can see here, if you try to select from a field that doesn't exist, so for example, you have like favorite sugar level, user, error, no such column, favorite sugar level. So you can both only insert and select from columns in the table that exist. So say we have like there's a new trend, and then all of a sudden everyone likes golden bubbles instead of regular bubbles. So let's try update from the table. So let's try update user set. Now we're going to set our favorite topping to now be golden bubbles instead. I only want to change my entry. I like golden bubbles. Everyone wants to stay the same. So my ID equals 1. And then let's select all and see if it updated. And here we see we have Jessica Thai milk. Now it's golden bubbles instead of just regular bubbles. And so now say I have a bad experience with the golden bubbles and I hate boba now and I want to delete my entry from the table. We can also delete from user where ID equals 1. That's my ID. And then let's select all from the table to see. And now Jessica's gone. Now it's just Shungo and Maria. And then finally, say I convince everyone Boba's awful. I want to delete the entire table. We don't need Boba's banned from app dev now. So now we can try delete the entire table. So we're just going to drop table user. And then let's check our tables. And it's gone. And now we're finished, and then we want to leave the shell. It's just simply .exit. Oh, oops. And that's it. We're back to a regular terminal. Does anybody have any questions? No? Okay. Do you want to start the
Okay, so that's kind of an overview of SQL. Thank you, Jessica, for showing that. I guess we're much more ahead of like schedule than anticipated, so we can just get started with the demo code. So just quickly, if y'all are not really familiar with this, the way Jessica was going through previous commands really quickly, which all of you should use, is by hitting the up arrow. So this will like kind of scroll you through all of the commands that you've run in the past. Hitting down will, go more forward, and up is more backward. But that's just like, oh, oops, sorry. That's just a slight thing to know. When going through the commands that you've run in the past. Okay, is SQL actually comfortable with everyone? Like, is everyone comfortable with SQL? Does that make sense? It's very fun, very lots of text, but much more usable than Python dictionaries, I hope. So with the same commands that we ran last time, right? I'm going to be doing this we're both going to be doing this every single week. Code dot to open the current directory. Let's start looking at what is in our demo2 directory. So, right, we have basically a very similar thing as last week. We're not going to be, typing all this up again because all of you are probably familiar with it already. So we have a few endpoints, right? We have the base endpoint, the task endpoint, the create task endpoint, get task, update task, delete task. So all this is basically the same as what we did last time, minus the dictionary that we had for posts, right? So that's app.py. db.py, on the other hand, is a bit different and going to be a bit new. So let's discuss about what's in db.py. Okay, so we have OS. OS is your operating system. That's your computer. We're going to be using OS to, actually, I'm not really sure where we use OS, but OS is stuff that's going to be in your operating system on your local computer. So whether that be like files or something like environment variables, which we'll cover later. That's what this package is for. SQLite 3 is the library we're going to be using to write SQL in. All right, so same thing as what Jessica just showed. So that's what these two packages are. This singleton function, you can actually go ahead and click this link if you hit Command click on Mac or Control click on Windows, I think. But basically what it does is we have a database driver. The database driver is an object that like kind of represents the whole database, right? And we only ever want one instance of it running because we don't want to be adding data to it from like two separate like ends. We only want one database instance to be running at the same time. So that's what the singleton function does. Singleton allows you to only get one instance of a class ever. And so you can see down here that we have a database driver that we pass in through the singleton function so that only one connection to the database exists at one time, at any given time. Cool. And this database driver thing is something we're going to be writing code under. This is actually where we're going to be writing the SQL code. It's under the database driver because this is the class that interacts with the database, right? That's the whole point of it. So yeah, and there's like comments here to kind of like run you through what's going on here. Okay. So any questions so far with what the file setup is here? Does everything make sense? Only one connection to the database at a time? Okay. So we're going to be starting with the database file because the database file is going to define our table, define our, how we're going to be interacting with the table. And one important thing that I forgot to mention last semester is when you're creating a backend, you generally always want to start with the table design before the API design, before designing the routes. And that's because you want to have a foundation of like what your data is how your data is structured before you actually start implementing the logic on how to actually interact with it, right? So we're going to be designing the database by first defining what the table is going to look like first. Okay, hopefully that makes sense. Today we'll probably cover how to get connected with the database and then just stop it there. And then next lecture, Jessica will cover how to use the SQL functions to interact with the database. Right, so let's find out how to connect with the database first. So the way we're going to do that is by actually defining this init function. For those of you familiar with Python, init is like kind of like how to initialize this database object or database driver class. So if we define or if we initialize an object of this class, this function is going to run. So to initialize it, let's first write documentation on what this does. Here is a connection with the database. Stores the instance variable. All right, so again, this is going to connect to the database. And also, why is my Wi-Fi doing this? Okay, so it's going to connect it to we're going to connect to a database and store the connection into a variable called con for connection. Right, so let's do that. So the way we're going to define instance variables in Python is by doing self dot and then the variable name. So self.con equals SQLite3 dot connect. And so there's going to be two fields we can enter here. The first one is the name of the database file. The app we're going to be showing how to create in demo is a to-do app. So we're just going to call it todo.db. And this .db is going to be the file type of every database file you create in SQLite 3. So we connect it to this todo.db file, and we're also going to do same or check same thread equals false. This prevents us from making multiple edits to the database at the same time. There's actually benefits of setting this as true, but that's kind of outside the scope of this course, so we're not going to discuss it. Okay. Does that make sense so far? We just connected to the database, right? So when we connect to the database, what is the first thing we want to do? Let's think about it. So, right, we have this empty database file, and we want to actually start using it for our app, right? The first thing you would probably do is actually create the tables we're going to be using. So we'll do self, which is a function within this database driver class, self.create task table. Okay, and I'll end it right here. But next time, Jessica will cover how to actually create the task table, right? This is a function we're calling from the initialize function. So every time we initialize this object, it's just going to immediately get called, and it'll create a table. And then she'll also cover functions to actually interact with the database. So like retrieving tasks, inserting tasks, updating and deleting tasks. So yes. Does that make sense? All right, so we're probably gonna get started with the Kahoot then for today. Okay.